button. Okay. Okay. If everyone ready, you can download the slide. Okay, the slide will be from Moodles. Okay, chapter 5. Right? It's a chapter 5, Boolean operator. Okay, it's Boolean operator. Okay, so of course, if we manage to finish the slide early, okay, we will have another chapter. Okay, we will have another chapter for today's. It's regarding our branching statement and a list. The branching statement, also known as a control structure, which is the condition statement and the repetition statement, along with the list. We already learned list this week. So this week we learned about list. So I hope that we manage to learn as well the lecture, the slide. But if we didn't manage to finish, okay, the slide, don't worry. Okay, don't worry if you are not, okay, we can't finish the slide. You don't have to worry, as we can continue, okay, for next week. Just I didn't upload yet, okay, I didn't upload yet the slide for chapter 6, the slide for chapter 6, because I do some editing just now, okay. I look some thing that we can remove from the slide, and okay, then we continue. Okay, so let's continue, guys. Chapter 5, Boolean and operator. Okay, here we go. The slide for this chapter. Oh, okay, so the slide for this chapter, as you can see, is only 15 slides. So of course we can manage to finish it up earlier. So why we learn Boolean and operator first? Okay, because later on in our branching list, we already learned in the tutorial. We use a lot the Boolean expression and the operator, okay, inside our control structure or the branching. Okay, the branching statement, the repetition, the condition statement. So we use it a lot, the Boolean and operator. So we go through the details of Boolean operator and the Booleans. The Booleans and operator. Sorry, guys. Miss Azia. Also, suddenly become shocked because some of you saying that one of our friends get caught by police. Why? Okay. Okay. Where is the slide? Okay, here we go. So come on. Okay. So today we will learn about the Boolean operator, computing with Boolean algebra, and the operator. Okay, so at the end of this lecture, you will be able to identify what is the Boolean expression. Actually, we already know what is the Boolean expression, okay? And apply the Boolean in programming. And we had applied. We are done apply the Boolean in programming. So the Boolean is something like, okay, the condition is either true or false. The answer is either true or false. So when we create the stopwatch last time, so we said that either the condition is true, then it will goes to changing the hours into 1. When the minutes, okay, equals to 59, which is true, and the seconds equals to 59, which is true as well, then when it comes to true, and the answer become true, then it will goes to the statement. So where they will change the hours into 1. So that is Boolean expression. It will return the value either true or false, 0 or 1. Okay? It will be in a binary number, 0 or 1. Okay. Okay. Let me start. Proceed. Okay. So this data type only have 2 possible values. No other values. It's either true or false. It's similar like when you have if, okay, if age greater than 18. So when you enter the value 17, is it true or false? Is it 17 greater than 18? I'm asking you. Is it 17 greater than 18?
No, miss.
No, so the answer is false. So the answer will false. They're either false or true. So use this data type to track the true or false conditions. So in programming, a Boolean expression is an expression that either true or false. So in BYOB, any block shape with the reporter block, if I'm not it's not a reporter block, it's a predicate or reported block. This one, the block with this rectangle block, that is the Boolean expression. The one with this one, I show you, I draw lah, I draw for you. The one with this shape, this is a Boolean expression for okay, for BYOB or snap or scratch. Okay. Clear? So with Boolean expression, you can construct a control structure statements. That's why I say we need to learn this chapter first before we go to the next chapter. Okay. So Booleans means roughly one of 2 possible states. It's named after the creator, George Boole. Okay, George Boole. So it's either true or false, on, off, in, out, open, close. Only that. So the keywords we use is and or not, but we don't have XOR in our BYOB or scratch or snap. We only have the 3 keywords, and or not. If in other programming language, we have, okay, XOR, okay, the exclusive OR, and we have many more. But in BYOB or snap or scratch, we only have these 3 and or not. Okay, so computing with Boolean, George Boole, a British mathematician in 1815 to 1864, said that logic and maths are equivalent. All maths functions can be determined using 3 primary logics operator. So these are especially useful for searching databases. So N is narrow your search, or is broaden your search, and not is used to exclude the concept. So based on these 3 circle, we can call it a union. So which one is and, which one is or, and which one is not? The first one, and or not?
And.
The first one is and, because it's narrow your search. Second one,
Or.
or. The third one,
Not.
not correct. Okay. The first one is and, second one is or, and the third one is not. So because and, narrow your search, or broaden your search. Not, it's either exclude concept. If not true, it will be false. If not false, it will be true. So it will be, if not fruits, so it will be apples. If not apples, it will be fruits, something like that. Okay, so it will be yellow is the search target. So this is and, this is or, this is not. Okay, let's we go to the Boolean operator. Okay, so Boolean operator used to combine two Boolean expression and produce a Boolean result. Okay, so two tables capture the output or value of a Boolean expression. So a column for each input will plus the output, a row for each combination of inputs values. So this is example. Okay, so we have the input A and B. We say A is 0, 0, 1, 1, which is false, false, true, true. And the input for B was 0, 1, 0, 1, false, true, false, true. Okay, and when we say A and B, 0 and 0, false and false will become false. False and true, it will become false. True and false, it will become false. But true and true, it will become true. Different with or, because it's broaden the search. When we say broaden the search, false or false, it become false. False or true, it become true. True or false, it become true. True or true, of course, it will become true. Okay, not B. So you need to see the input from B. Not false, true. Not true, false. Not false, true. Not true, false. If you ask me how you get this one, you go and ask George Bull. Okay, because this is created, the truth table created, okay, by him to make us easily. We just need to understand false and false because it won't be more than this. Okay, usually it will be only the four logic. Okay, so the four input is either true and false. So it's either false or false, it will become false. False or true, it will become true.
Excuse
Okay.
me, miss. Ma'am, can you explain that table again? 0, 0, 1, 1.
This one is true table, something that you need to memorize it. Something that you need to memorize it.
Okay.
Okay. But of course, I will show you in algebra. Okay, I will explain in the algebra so you will know. So, in the two tables, okay, this is another example. Okay, wait, I close the pen. So, P and Q represent smaller Boolean expressions. So, since each expression has two possible values, so there are four possible combinations. So, if true and false, it can be true, it can be false. So that's why they have four possible combinations, true and true, true and false, or false and true, and false and false. This is the four combinations. So this is the true tables, the result that you get when you say P and Q. True and true, it becomes true. True and false, it becomes false. False and true, it becomes false. And false and false, it becomes false. Okay? So, for all, it will only false if both expressions are false. Otherwise, it will become true. Same as the first two treble for n, we have four possible combination, which is we have three true and false. So we can have true and true, true and false, false and true, and false and false. So same as or, okay, same as or, we have true or true, true or false, false or true, and false or false. So it says here, it will only false when both expressions are false, but it will be true when either expression is true. But, okay, true or true cannot be false. True or true must be true. Okay, so this is just only for your knowledge. XOR reports true if both inputs different. It will only reply true. So if you have XOR Q, so it's only report true if only your inputs different, true or false, false or true. So the answer will become true, but the rest will become false. But we don't have this in BYOB, Scratch or Snap. So is it clear now how you get it?
Yes, miss.
Okay. Okay. So let's, okay, when we say NOT, so the NOT operator computes the opposite of Boolean expression. So NOT is a unary operator, meaning it operates on a single expressions. So when we say not true, false. So not false will become true. So we can put all these together if you have it in AND statement, okay, or OR statement, okay, or the OR Boolean and AND Boolean. So we can put together to make arbitrarily complex Boolean expressions, something like this. When you have this, it will be totally different. P and not Q. So you will do the not Q first. Not Q, not true is false. That's why true and false, it become false. Not Q will become not false is true. That's why true and not Q is true, because this Q already become true. So true and true become true. So false and not Q, not true is false. So false and false become false. That is how you read the Boolean expression. So when you use the Boolean expression in your program, in your condition, make sure you put it in correct way, because put in the Boolean expression wrongly, it may lead you to get a wrong result, a wrong output. Clear?
Yes, miss.
Okay. So now, if you want to know more clearly, we go to the Boolean algebra. So the ability to formulate, manipulate, and reason with Boolean expression is an important skill. So Boolean expression obeys certain, okay, algebraic laws called Boolean logic or Boolean algebra. So it's similar. 0 corresponds to false, 1 corresponds to true. So when we have this algebra like A multiply 0 equals to 0, so A and false equals to false, A multiply 1 equals to A and 2 equals to A, while A plus 0 equals to A means A or false equals to A. That's mean we can say that in algebra, N has properties similar to multiplication, while O has properties similar to addition. So that's why we get A and false. That means 1 and 0 equals to 0, false. 1 and 1 equals to 1. 1 or 0 equals to 1 because true or false equals to 1, true. So that means N has properties similar to multiplication, okay, or has properties similar to addition. Okay, that is the easiest way you want to remember. Okay.
Yeah, miss.
Okay, so Boolean operator. So let we see this example. I give you one example like for a volleyball scoring. So correct me if I'm wrong, okay? So in volleyball, a team wins at 15 points. Okay, we have a team that wins at 15 points, but a volleyball team needs to win by at least 2 points. So if the score is 15-14, they will play continuous just as it does for 21-20. So can we make an algorithm without a Boolean operator? Can we make this without a Boolean operator? Means we just straightforward, right? If score 15-14 and if score 20, can we create without a Boolean operator, means without using AND operator, OR operator, or NOT operator? Can we? Can we, guys?
I don't think so.
You don't think so? So if you don't think so, cannot, okay. You say cannot, okay. Okay, you don't think so. So it's gonna be hard. So we try to write, okay, this into a Boolean operator. Means we insert the AND or not. We use the AND or not. So we use it. So try to write something like this. Okay. Try to write something like this. I will show in the whiteboard. Okay, something like but I think we already have the, okay, we already have the answer. Everyone already have the answer. That's why you don't want to do it, eh? That's why I don't want to give the slide before the class usually, because we have the questions that we need to answer, eh? So some of you already get the questions, okay, so they already get the answer, so you can have it, because remember, it's 15-14. So we know that we don't have equals, greater than equals. So it's either score greater than 13, it will be 14, and score less than 16, it will be between 14 to 15. And score greater to 19, and score less than 22. So it will be between 20 to 21. So then you will say you win the games. So this is the correct way. You want to see you want to compare, okay, or at least you must have 2 points, okay, to win by at least 2 points. So it's either, okay, 14, 15 or 20, 21. At least 2 points. So it will be N. It's not or, because or is either one. This one you say at least 2 points. It's not at least 1 point. So if at least 1 point, you can use or. So when you use or, okay. So when you use or, then it can be either one. This true or this true, then you can say you win the games. Okay? Clear? Clear?
Yes, miss.
Okay. So can we proceed?
Yeah, let's proceed.
Okay. So next, okay, that is Boolean. Any question regarding a Boolean operator before I proceed to the next, the next topic, which is operator. Operator, arithmetic operator, logical operator that we had in our programming. So, any questions before I proceed?
No questions from me.
How about others? Any questions? No. Any questions? No. No question, eh? Okay. So, no questions. Very happy to draw on the whiteboard, eh? Okay, so if you don't have questions, so let me proceed to the next part. Let me delete this first. Okay, so here we go. Okay, so from here on, we will use all operators. You may not must not use them in your pseudocode. You may use them or you may not use them in the pseudocode. Okay, so here we go. So if you look here, this is arithmetic operator. So we have the plus, minus, multiplications, okay? We have the addition, subtraction, multiplication, division, and the modulus. We do have this in our SNAP and BYOB, we do have this in our SNAP and BYOB. So this modulus is to get a remainder. What is remainder? Something like this one. So let's say I have 6 divided by 4. Means the question is 6 modulus 4. Okay. So this modulus is divide actually, but we get the answer from the remainder. So 6 modulus 4, it will be 1, 4. And then 6 minus 4, 2. This is the answer. So the answer for 6 modulus 4 is 2. We don't finish them by 1.5. No, because this is not division. This is modulus. Modulus means we get the remainder. Okay, in Malay we call it baki. In English we call it remainder. This one. So that's why the answer was 2, not 1. I keep hearing someone. Okay, unmuted yourself and okay, your chair. Okay, please, guys. Okay. So, is it clear for the remainder for the modulus? Is it clear, guys?
It's clear.
Clear. Clear, guys? If clear, we can continue. So this plus plus or minus minus is increment and decrement. This one in snap or BYOB or scratch, we can find them in change block. Change by 1, change by -1. If you still remember, we do have this change. We always use when we have the repetition, not repetition, when we use the condition statement, the if-else statement, we change the value, okay, the variable by 1. So that is increment. It can be plus plus or minus minus. It can be either one. Okay, clear? So plus plus mean plus 1. Okay, minus minus mean minus 1. That's why we always change by 1. But you also can have more than 1. Let's say plus 2. So that means they will plus by 2. Every time they loop, they do the repetition statement, they will plus by 2. This one you will learn detail in our repetition statement in branching chapter after this. Okay, clear? Then we have relational operator. But as you can see, not all relational operator we had in our snap or BYOB or scratch. Not everything. Okay, not everything we had in our snap or BYOB or scratch. So if you look, we only have less than, greater than, and not equal, which is we can create them. We have the not equal. We can create them, but actually we don't have it. And we don't have this equal sign. This equal signs means usually we want that your condition must equals. We use this in other programming language. We use this sign in our Boolean expression in other programming language. But in Snap, in BYOB, we just learn using the single equals. Okay, just using the single equals. So we also have, okay, in other programming language, we also have this less than or equals, greater than or equals, okay, equals to and not equals. We can create one, but it will be a long program. But don't worry, okay, even it's a simple relational operator, it's still working, okay, it's still working in our snap or in our BYOB or scratch. So we also have the logical operator, the one that related in Boolean expression, not, and, or. Okay, in other programming language, they use a symbol. Okay, not, ampersand, and this or symbol. Okay, the ampersand and this or symbol. Okay, so when we create an operator, a mathematic expression, okay, especially the arithmetic expression, when we create them, make sure you need to follow a basic rules about the order of evaluation. You need to follow the order of the evaluations, which is, if you have the bracket, the parentheses, you must finish the parentheses first. And then if you have the exponential, then you must finish the exponential, then follow with the multiplication, division, addition, and subtraction. So we can call it as, please excuse me, okay, please excuse my dear Auntie Sally. Please is for parentheses, SQs is for exponential. Okay, dear, okay, mine is for multiplication, dear is for division, auntie is for the addition, and Sally is for subtraction. So some of you have your own, okay, terms, okay, on how to remember this order, okay, the order of the evaluation. So you may use your own, but make sure when you wrote the expression, okay, the mathematic expression, make sure you follow the order of the evaluation. Okay, clear guys? Okay, because if you wrongly follow, okay, the order of the evaluation, we afraid that you might get the wrong output. It causes you to get the logic error, which is we don't want to get the logic error. Okay, clear?
Yes, miss.
Okay, we break for 10 minutes. Next, we will go to the branching statement and list. Okay, because we still have time. Okay, so we will break for 10 minutes. Then after that, we will continue to the branching statement. You go if you want to go for a toilet break, you can go. Okay. Otherwise, you can just wait in front of the computer. I cannot go straight. Otherwise, your brain will be freeze. So we break for 5 to 10 minutes. Okay. I have uploaded, okay, the chapter 6. You can download, you can download from the Moodles, chapter 6. Yes, it's a 10 minutes break. Okay. Already 10 minutes, guys? No? Okay. Okay, we have 5 minutes more. Don't worry. Okay, I keep my promise, so don't worry. Okay, done, eh? So already 10 minutes. So let's continue. So is everyone already in front of your laptop?
Yes, miss.
Yes, eh? So let's proceed. Okay. Maybe not. It's like a chismo. Now you see, now you don't. Okay. Okay. Download. You already download the slide? We have some questions exercise in the slide, but not in your slide, in my slide, okay? Okay, so let's proceed.
This is this chapter 5 or chapter 6?
Chapter 6, yeah. The file name also chapter 6 is branching and lists. Okay, so let's proceed. So what we learn in this chapter is chapter 6. Why is chapter 5 here? It's chapter 6, guys. Okay. I hope I give you the correct file, eh? Okay. This chapter 6, guys. Okay. Edit something there. Okay. Since we arranged the chapter, so it become chapter 6, this chapter. Okay. So here we go. You guys can see my slide? Cannot. Why suddenly didn't share the slide? Okay. Now you can see my slide. You guys can see my slide?
Miss.
Okay, good. Okay, what you will learn? Actually, we have learned all this in our tutorial class. Okay, we have learned all these four in our tutorial class. But of course, in our lecture class, we will go through, okay, the theory part, the theoretical part, especially how you want to, okay, to write them in a pseudocode, how you want to draw them in a flow chart. So we will learn them in our lecture class. So here we go. Okay. So topics cover control structure, which is we have the selection statement and repetition statement or looping statements. This selection statement also known as conditional structure. Okay, as a conditional structure. Okay, so here we go. And then the last one will be the list. Okay, the last one will be the list. Okay, so at the end of this lecture, we will be able to differentiate between if and the if-else statement. Actually, we already know what is the if and what is the if-else statement. Okay. Identify the control statement in BYOB or snap or scratch, because it's not only if and if-else statement we have it, but in other programming language we have only if, if-else, if-else-if, and the switch case. But in our snap or BYOB or scratch, we only have the if and if-else, and the rest is something new in our visual programming. So identify the use of list in programming. Why we need to use list in our programming. Okay. Control structure. When we say control structure, it's a program that consists of a number of statements which are usually executed in sequence. Okay, we execute them in sequence. Okay, and then programs can be much more powerful if we can control the order in which statements are run first. Which one to be run first? If we can control, then your program will be powerful. Okay, The contour structure let the program makes a decision about what to do next. You just give the instruction, then you let the program make the decision what to do next by their own. You don't have to think or figure it out. Hey, what I want to do after this? No need. You just give them the instruction and then the program will do or make the decision for you. That is the control structure. So when we say control structure, we have some theorem, okay, theorem for the control structure. So actually we have 3 theorem. First one is the sequence, the one that we do one by one without having the if-else statement. Remember in our first tutorial, we do it manually one by one. So that is a sequence, means we straightforward execute them without, okay, any condition or without any instruction to, okay, that instruct you to do the repetition statement. Nothing. We only do one process step to another process. So for example, like when we create the list this week, at the beginning, we didn't use any repetition statement. We just ask the name, we just ask the score, and then we just insert the name and the score into the list. So that is what we call as a sequence structure. Okay? Clear?
Yes, Miss, it's clear.
Yeah? Okay. So then we add the selection or condition. So we also have the selection or condition structure in, okay, in the control structure. So it's a choice between 2 actions. So this choice based on or depending on whether the condition will evaluate true or false. If true, what you will do. If false, what they will do. The decision what they will get or they will display to you. So you have the choices between true or false or nothing. That's why we have the if statement. If statement means you don't have the choices. You only have one. Means if true, what they will do. If false, they will do nothing. They will just stop the program. Okay, just stop without doing anything. So that is the difference when you have a choices and when you don't have any choices. Okay. So now let's we proceed. Then the third theorem, which is repetition. So this repetition is a sequence of instruction to be performed as long as the condition evaluates to true. That's why they repeat. Repeat. As long as the condition is true, they will just keep repeating. They will just keep repeating the statement. As long as it's true. We are the one need to put stop. Otherwise, it doesn't stop. But in our condition, we have this repeat statement. So when we say repeat 7, so means when the condition already meets to until 7 repeats, okay, then they will stop. Okay. Then evaluation represent the decision-making abilities of the computer. So a computer can evaluate an arithmetic expression and select a sequence of action. So that is what we can do. So let's we go one by one. Since sequence is very easy, we know it's just straightforward without a condition, without a choices. So let's we go to the selection statement. Okay. So this selection statement, what we have it, okay, in our selection statement. So in a programming, when I say in a programming means in other programming language, in other programming language. the general one. So a condition is something that must be true in order for something to happen. So it must be true. Okay, so if false, then they will go to, okay, it will go to the next statement. So a condition is thus said to evaluate to true or evaluate to false. So in BYOB, any block labeled with if, when, or until is a sort of conditional construct or structure. Okay, any label with the if, when, or until is a sort of conditional structure. Okay, in BYOB or Snap or Scratch, but in other programming language, they only have if else, if, and switch case. That is the difference. Okay, so next. Two types of selection statement that we have in our programming language, okay, in our BYOB or Snap or Scratch, if and if else. This is the usual one, okay, usual one. So I will just showing you this one first, okay, I will show you the first one, this, okay. Okay, if else. See the difference between this flowchart. Don't worry, I will explain to you. I will give you another example with the explanation. Okay, and I hope with that example you guys will have more clear view. So see the difference between these two flow chart. What you guys can see from here. What is the difference?
Difference is if it is false, then there is a body of else.
This one is if, this one is the if else. What is the difference?
Miss,
Yes?
I think the difference is that one of them just like, okay, so there's if and there's if of else. I think for if, regardless of what happens, your sorry, if the text expression is true, then the if statement is going to play out. If it's false, it's going to go directly to the exit. And for if of else, if the text expression is true, the condition for if is going to play out. Or if it's false, then another condition is going to play out. I
Okay.
think that's the difference.
It will be, it's not play out lah, it will be display lah.
Yeah, display, sorry, yeah, my bad.
Okay. So if you can see here, for the if statement, okay, if the expression or the condition, the Boolean expression or the condition was true, they will display the body of the statement, the body of the if. Okay, which is maybe you have a say statement, or maybe you have another things, okay, like remember in our stopwatch, we said that our hour changed to once, okay, when the condition is true. Okay, but if our condition or the expression was false, nothing will be done. Your program will just stop. So if you don't believe me, we can try. I'll give you one example. Okay, this example. Okay. Oh, Aiden is answering. Okay, let me read first. Body of else. Okay. Yes, miss. Maybe. Okay. So I'll give you one example. It's not your attendance. Okay. I give you one example. So this is if statement. So let's say this example, I will show you how to write in the flowchart. So I say that I have a variable named grade. Okay. At the beginning, I say my if statement is if grade greater than 50, Okay, because we know that greater than 50 means pass. Okay, so pass. So we will say pass. Okay. And then let's say we do the the green flag click. You ask the questions, enter your grade. Okay, enter your grade. Okay, enter your grade and we set the grade to answer. Okay, we set the grade to answer. Okay, then we have this. We just simple one. So this is the if statement. Enter your grade. So I enter 45. Nothing. Because there is no, the condition is only one choices. Either true and no false. Okay? True and no false. But different if, okay, I will duplicate the whole body. Different if we have the if else statement as Ashfa mentioned just now. Okay, correct, what Ashfa explained. Okay, we say pass if grade greater than 50 and we say fail if we enter other than 50. So we can say it's 49 lah actually because it's greater. So I won't use the same click because otherwise it will be confusing. So I will use another one, space key press. So I will press a key press so they will run this block. So I will enter 43. They have the choices. They have the choices. So if the condition is not true, false, they have another decision to be displayed. Like for the first one, the if statement, they don't have any other decision to display. So they will just stop if your condition was false. Clear? Clear, guys?
Yes, Mass, is clear.
Clear, everyone?
Yes, miss.
Okay. Okay, so next, let's go to our slide back. Based on this given example, I will convert them into a flowchart. Okay, using the given examples. Okay, you guys can follow. Okay, you guys can use it. This one is for the if statements. You guys can draw the example, okay, as well with me, along with me, don't worry. So I will use the shape, no shape, so I need to use this shape. So you can find it from here, flowchart shape. Remember to have your start. Okay, remember to have your start. This is your start. Okay, then we have the input, right? Just now we input the grade. Okay, we input the grade. So input, what kind of shape is input? What kind of shape is input? Input, what shape we use for input? What shape? Ha ha ha, forget already. Go check chapter 2. What shape? Input, output. What shape? Ah? Huh? Open chapter 2, guys. Go open in chapter 2. Input and output. Input and output. Are you sure it's square? I never teach you guys square.
Miss, is it parallelogram?
Yes, it was parallelogram.
Oh, you call it a parallelogram. It's a trapezium, guys.
It looks like a parallelogram.
Okay, this is the input. Okay, we use this as an input or process output. This is we call it as a trapezium actually.
Miss, I think that's a parallelogram.
But
I think so.
you think so? You guys can
Wait,
find.
let me check. Wait, let me check. Yeah, that is a parallelogram.
Okay, it's a parallelogram, eh?
Yeah, trapezium is something else.
Oh, actually, it's a type of trapezium. Okay, it's
Okay.
a type of trapezoid. Okay, so when we say trapezoid, so we have that parallelogram. Okay, but usually we call it trapezoid, but it's okay. You can call it as a parallelogram. Okay, but it's a type of trapezium. The parallelogram is a type of trapezoid. Okay, it's a type. Okay, we have that. We have that in the trapezoid. So we have the trapezoid can be the acute, can be right, can be obtuse, can be rhombus, can be three side equals, can be isosceles, and can be also parallelogram. Okay, so since you call it as okay, we can call it as a parallelogram lah, the one that you guys can remember, but it's type of trapezoid. You can find it, this one also is a type of trapezoid. Okay, so it's a parallelogram, but it's not square. It's not square. So you read the grade. Okay, you read grade. Means you input lah, grade, input grade or read grade. So up to you what you want to have. Then we have the set grade to answer. Okay, so that is process. Okay, process. Process, what process? Process shape. What is the process shape?
Rectangle.
Is
it a rectangle?
Yeah, correct. Okay, it's a rectangle. Okay, so it's a rectangle. So this one, this shape. Okay, so you can set to, okay, set grade to answer. You can put something like this. So then we have the condition. If grade greater than 50. So greater than or condition, we use the diamond shape. This diamond shape for the decision. So when you have this diamond shape, okay, we use this diamond shape. You don't have to write the if grade. You just put grade 50, something like this. Okay, so grade greater than 50. So if grade greater than 50, this one is if statement. If grade greater than 50, then you will display pass. So display is which shape? Display which shape?
The trapezium.
It's a parallelogram. Okay, I also will use this term. Don't worry. Okay, we can use this term. We learn something. Okay, we learn something that this one is type of a trapezoid. Okay, so it's a say. Oh, please mute yourself. Okay, and then terminate end. Okay, end. So this is a termination. Okay, end. So you can put it them in a range. Okay, like using a center or whatever. And don't forget to have the arrow. It's arrow, guys. It must be arrow, not, okay, it must be arrow, not line, It must be arrow. So the arrow must be going down, like this. Okay, you can attach them since you use the, okay, you use the shape. So you can attach them. Okay. Done. Okay. When you attach means it become green color, so then, no, this one. Okay, this one. Okay, but, okay, okay. So you must have the yes, okay, yes. Here, draw here. We can delete first lah, this one, we can delete first this one. Okay, this one, then shape format. I don't like this, the presenting, stop presenting one. Okay, this one we put here, yes. So yes. So if yes, they will go here. So if no, we just copy this one. Okay, no need to bring another text box. So you say if no. If no, okay, you must have, when you have a condition, you must have this yes or no. Okay, so if no, what we will go? We will go to here. Okay, we will go to here. Okay, we will continue to here. We didn't do anything, we just stop. Okay, this is if statement. So this is if statement. You can draw on your paper, a piece of paper also can, you can draw. So this is the if statement. It's different. Okay, we don't have a choices. We only have this. If no, nothing happen. It's similar how it works in your program. If no, nothing happen. We already see the program just now. If no, nothing happen. Okay, but how about the second one? Okay, thank you, Samuel. Okay, thank you, Samuel. Is the name referring to the group of quadrilaterals? We'll pay of parallel side. Then one of it is parallelogram. Am I right, Samuel? We learn something new, guys? So, how about the second one? When we say if we enter the value less than 50, which is it will goes to fail. So you can copy. I will just copy, because we just need to do, the different will be, okay, the different will be only when you say no, no more this one. When you say no, okay, when you say no, we bring our parallelogram, okay, but then we can put anywhere we want. Then we say fail, okay, and we just go in here and they will be going finish, stop. Of course, it will goes to stop, but it has a display here. Not like this one, you just go straight to the end. But this one, this time around, if no, you will still display, okay, the you still display, okay, the output. Okay, clear?
Clear, miss.
Clear, everyone?
Yeah, miss.
Clear, miss.
Okay, clear. Okay, so now, how about if you have more than one condition? You have more than one condition. Especially if you want to check the score, either the grade is, okay, you said that if the grade greater than 75 is A, grade greater than 65 it will B. So you say something like that. So you have more than one condition. So how will be your flowchart looks alike? How will be your flowchart looks alike? So it will be something like this, guys. Let's we go here. Okay, I will change the layout into empty. So this one is if else if statement. I will use this one now. So because if, okay, else if, means you have more than one condition, because in BYOB you can create one, guys. You can create one. You can create it. So don't worry. We are the one who create the code. We are the one who program the script. So we can create this if else if statement. So if you have more than one condition, okay, if you have more than one condition, example, I give you from the snap, I give you the from the snap. Add more diamonds, correct, Harish. But you must know, you must also have the no statement. It will be different way you write it. Okay? It will be different way you draw the flowchart. If previously, okay, if previously in if else statement, where is my flowchart? Okay, if previously in my if else statement, the no one will be inside here, the yes one will be here. But when we have the if else if, it will be different. So I will show you if, let's say, we have more than one condition. Of course, we need to add more, okay, more diamonds. But I give you another example. If your structure, when I'm click, okay, so you say that enter your grade. I will just duplicate this one. So I will not use this one anymore. Okay, I will use if else. Wait for a while, Okay. I'm closing my my door, okay, because just now my husband is going to work. I'm afraid living alone in my house, so I open all the door. Right now he's coming back, so I need to close, otherwise you will hear everything. Okay, so when you enter your grade, so we say that if, okay, if grade, you say if grade, I give you one example, very simple example. Don't worry, if we didn't manage to finish today, we can continue next week, so don't worry. So if grade greater than, I say just now is 75, okay, 75, and then you will say A. Very simple one, So then we have another else if. I will just use two else if. If else if, okay, that's mean if grade, this one I will use and statement because we don't want them to, okay, above 75, okay, meet the 75, so I will use and. If grade greater and less, okay, so it will be have 2, so when you have 2, make sure you know how to call it. So if grade greater than 64, 65 and above, and less than 75, meaning until 74, so you will say B. Okay, so this one is 74 lah, because we want to have 75, right? So else I will just have, okay, and then I will just have 3 condition, another condition. So if else if, so I will just copy this one, duplicate this, put here, grade greater than 49, which is 50 to 64, so it will be 65. So I say it's a C. Okay. C. Just duplicate this. And then otherwise it will be D. Okay. Otherwise it will be D. So we have 3 different conditions. So when you have these 3 different conditions, so how you want to write them in a flow chart? Okay, it will be a multiple diamond. So here we go. Okay, here we go based on the example given. Okay, so we will use this one. Okay, we will use this one. I will just have this starting from here. Okay, only from here. The rest will be different. Okay, I will have it starting from here. So no. Okay, then okay, no, it will be here, no, and then will be yes, it will be here. Okay, I will change it, grade greater than 75. Okay, so when you set grade greater than 75, so let me share the whole screen now, better, because I want to open the no, why, because I want to open the, okay, Chrome as well. Okay, so here if greater than 74, okay, 74. So if yes, okay, if yes, then we call our parallelogram here. Then we will print say A. Okay, if no, there was another condition, but this condition will be long, grade greater than 64, and you can use and, or you can use this ampersand. No, it's okay. And grade less than 75. So correct, this is what we do. Okay, yes, correct. Okay, so it will be no. It will be no. You make it until it can fix lah. So no need to put the if statement, guys. No need to put the if statement. So it will say B. So it will be repeat. Okay, Control C, no, no. When no, another condition. When yes, it will go to this. Okay, no, yes, no, yes. So this is the way we wrote them. So at the end, okay, so we have no. Okay, so I will just stop. Let's we imagine that we have it more because not enough space. Okay, so let's we imagine that we have more. So I will use the dot line. We will change the line. Okay, we will change the line shape format. I don't like this the black color one, presenting, not presenting. It's disturbing. Okay, so let's say, okay, we imagine that this one, it will be no. Okay, so it will be the line shape outline. So let's say we have a dash. Okay, so the dash one, we means we have another, okay, decision. Okay, and then the last one, no, it will be D, right? So it will be D, so we can say, otherwise it will be D. Let's imagine we have another one here, and then we stop. Okay, we stop using the N. The N you can put anywhere, as long you have the N. You must have the N. Cannot if you don't put the N, so you must put everything connected to N. Okay, everything connected to N. Everything. So this one, they will connect to this, okay, arrow. Okay, this one will be connected to this arrow. You must, okay, you must put here, so you must change. Okay, so you must put, okay, so it will connect to each other. Make sure you have the all link. So all link to the shape. So you must link them. So even though it's a yes, it must be at the last one connecting to, okay, okay, the last one, it must be connecting to the end. It's not directly, it's not directly, but in between of the line. They will not directly. So it will be, doing your individual project, it will be very complicated link that you have. So this is what you can, you will do, Okay? Clear, guys? I don't know what to say because this is usually what we did. But maybe we join using that link. Okay, this is what usually we did. This is what usually we have it. We don't straightforward going, but you can we can have it. We can have it. But you must like if you want to do like directly can. Okay, if you want to do directly can, but everything must be like this. Okay, this one. Okay, so this one also will be connecting directly to this one. Okay, so it's usually it will be like something like this. It's something like this, but it will not see the double line. It will be like only we see only like this one. Something like we straightforward, something like this. We connect them. You can have this, the one that I show here, because it's okay. Suppose it will be in one straight flow chart, but as I mentioned, it's not enough space. So you can have something like this directly, but usually we only have one. Okay, one going to end, but you can have also something like this. So you also can have that it connect to here. Okay, you can also have it connect to here and it will go in one line. Also can. Like that also can. Don't have any problem. You can also have like something like that also. But usually we don't straight going to exit because after, okay, because usually after your if else statement, you will have another statement, am I right? Means outside your if. For example, like this one, okay, you may have the statement outside of the if. That's why we don't directly goes to end, because usually after your if statement, you may have something like maybe you say that your sprite glide, okay, out. So this statement will replacing this area, okay, will replacing this area where you can connect them into the, okay, sorry, this one is not enough, okay, so you can have it something like this. So we add another statement because usually we not stop until our if else statement. Usually after the if else statement, we continue having the statement block, okay. So that's why so when you have that, okay, like say you have a motion is an output because it's a glide, right? You can see the motion. So you say, okay, it's motion. You just say motions. So this motion, okay, everything A, B, C, they will connecting to motion. Okay, they will connecting to motions, like this one. Okay, after that, either one, it will be go to motions. Okay, this one also, they will go to motions. Okay, then B also, after that it will go to the statement motions. Okay, and this motion will go straight to the end. So this is usually what we have it, but we don't have just now because we don't have this motion, we straightforward to the end. So now clear, Harish, now clear everyone. Okay, we don't stop until our flowchart, until our else statement. We do not stop there. Usually after our else statement, we have another statement, just like maybe not glide, maybe you will play a sound, maybe you will say goodbye, something like that, but you don't stop. You didn't stop there. You didn't stop here. Maybe you insert into a list, so you will have another shape that will connect with your end. So now clear. Clear, guys?
Oh yes, miss, it's clear.
Harish, is it clear now?
Yep, miss, I understand better now.
Excuse me, ma'am.
Yes, Saad.
Ma'am, I have a question related to assignment.
This is not about assignment yet.
Ma'am, you have given programming assignment, right?
Yeah, you can ask me personally.
Ma'am, I have a little question. Can I ask, if you don't mind?
You can ask personally in a meeting chat, in my chat, in my Microsoft Team chat, as right now we are having a class.
Okay, ma'am.
Okay, guys, now it's a class. You should listen to my class, not doing your assignment. Okay? Okay. So, have you clear with the flowchart for the selection statement?
Yes, miss.
Okay. So next we go to the next slide. We will stop at 6:15. The rest of the slide we will continue next week. Don't worry. Okay. Okay. So here we go. So this selection statement we can see, okay, in Snap, in BYOB or in Scratch, we have the if else, and we also have this forever, if and repeat until. Even forever and repeat is a repetition statement, but remember this one, guys. We always can combine the repetition statement with the condition statement. Even in other programming language, we combine them. In a looping, we have the condition. Okay? When you use this rectangle shape, Okay, this will report true if the expression is true. So you can use forever if to make a condition. Make a condition like, oh, you don't want that your program to foreverly looping without stop. So you give them a condition that they will repeat until they meet the condition. That is what we use in our tutorial this week. Okay, the jokes tutorial. Okay, so Boolean expression, when we use the Boolean expression, it will always evaluate true or false. Okay, so selection and iteration also, this one, forever if and repeat until is named as selection or iteration because it will be iterate, increment. Okay, use Boolean expression. So sometimes simple expression are not enough. That's why we need and, or not. Okay, that's why we use just now a combination of and, because a simple expression using a greater than or lower than, okay, or less than, it's not enough. So we need to combine to get a better result. So we can use the and or not, the true tables. Okay. So here we go. The meaning of the if the condition is true, run the block inside, then go on to the blocks that follow. So if the condition is true, run the blocks inside the if portion. If not, run the blocks inside the else portion, then go on to the blocks that follow. So if forever, they will check to see if the condition is true. Whenever it is run the blocks inside and check the condition again. If the condition is true, then they will stop. Okay, so this is the if structure more detailed. So always evaluate the condition at top of the if structure, this one. Might execute one or nothing. So if we have this, if mouse down, when you click your mouse, they will say hello. When you didn't click your mouse, they will not say anything, stop, doing nothing. Okay, so if else structure, always evaluate condition at top of the if else structure. Boolean expression true or false. That means just now, if you click the mouse, it will say hello. If you didn't click the mouse, it will say goodbye. Just now didn't do anything. So this is the if else statement. Okay, so as I mentioned, we also have other than the if else statement. We have when, we also have the wait until. So when construct is instruct a sprite to do something when an event occur. When press key press, when A key press, when green flag when the green flag click, so it will instruct your sprite to do something. Wait until will instruct a sprite to wait to do something until the condition is true. Okay, so here we go. We stop here now. So what is the answer, guys? The price of the ice cream is 100 coins. Analyze the script presented below and select the correct statement. Which is the correct one? A or B? A or B, guys? A or B? Answer, guys. A or B? B. Saad say B. B. Pritisha say B.
I think it's B.
Ashfa say thinks B. Okay.
No, wait, no, it is B. It is B.
English
It is
B.
100%.
Okay.
It's not both.
Dilarang say B. So, okay, guys. Let me get your answer. Okay. Not both. Why you say not both? Why you say not both?
Because the statement says if the ice cream is more or less than 100, it doesn't say equal to 100.
So you say not both.
Yeah.
But that is not the answer. Because of course I will give you the question with answer. Okay, so guys. So vote. If you say A, click the like button. Okay, in my chat. Okay, from the meeting chat. If you say B, click the love button. Too many. Okay.
Miss.
Yes. Yes, Ashfa.
I think both of them are right, but B is the better answer out of the two.
Okay. Okay. Few of you, Sutesh, Ashfa, and Samuel say both. Okay. Okay, guys. The answer, okay, both correct means yes, basically. Okay, guys. Read the question carefully. The price of the ice cream is 100 coins. 100 coins. Analyze the script presented below and select the correct statement. So, for the first statement, if the coins for ice cream is hundreds, ice cream less than hundreds, that means 99 and below, doing nothing. But if the price of the ice cream is hundreds coins, if ice cream greater than hundreds means 101 and above, I can't buy ice cream. But hundreds, I will buy an ice cream. So the answer was B. Okay, congratulations to 16 of you who choose B. Congratulations. The answer, okay, for those who choose after my explanation, not count, only 16 students who choose B. Congratulations for your correct answer. Read the question carefully, guys. They said ice cream, okay, price 100 coins. If you run the code, it has been tested. I will also, okay, I will mention again, I will not giving you something that not working. Okay, so because the ice cream price is 100, the ice cream price is 100. Of course, they cannot buy an ice cream more than 100. Read carefully, guys. The question here, the price of the ice cream is 100 coins. So you guys clear or not? Yes. That's why, okay, the first one, it won't work. You enter the ice cream price 100, it won't work. It does just stop because it's less than 100. When less than 100 means 99 and below. But when we use the if-else statement, okay, even though the first statement is, the condition is greater than hundreds, but you still can buy the ice cream because it's 100 is including in else statement. So, clear? Clear, guys? You guys can screenshot this and you guys can try, You guys can try, enter the value of the ice cream, hundreds. You guys can try, okay? Writing in a snap. It has been tested and it's working. As I mentioned, I won't give you a question without testing first. That is the reason, guys. You must read the questions carefully. That is what you need to do as well in your lab test in week 7, not next week, week 7. Next week, week 6.